Hello. In today's episode of New Paradigm AI Research Summaries, we'll be exploring the fascinating subject of ZebraLogic on the scaling limits of LLMs for logical reasoning. This study comes to us from the esteemed researchers at the University of Washington, the Allen Institute for AI, and Stanford University. Now, let's dive into this intriguing exploration of how large language models, or LLMs, handle complex logical reasoning tasks. While these models have shown remarkable abilities in understanding language and even exhibiting common sense, their capacity to solve intricate deductive problems remains a challenging frontier. The researchers introduced ZebraLogic, a comprehensive evaluation framework designed to assess the logical reasoning capabilities of LLMs. At the heart of ZebraLogic are logic grid puzzles, also known as zebra puzzles or Einstein's riddles. These puzzles are a classic type of brain teaser that require pure logical deduction to solve. They involve multiple variables, each with a set of possible values, and a series of clues that constrain how these values can be assigned. The goal is to deduce the unique configuration that satisfies all the given constraints. To structure these puzzles mathematically, the researchers used what's called Constraint Satisfaction Problems, or CSPs. In CSPs, you have a set of variables and a set of constraints, and you need to find assignments to the variables that satisfy all the constraints. This framework is particularly useful because it allows precise control over the complexity of the problems. The puzzles can be made more or less difficult by adjusting the number of variables and constraints. In their study, the team created a dataset of 1,000 logic grid puzzles with varying levels of complexity. They measured complexity in two ways: by the size of the search space, the total number of possible configurations, and by using the Z3 SMT solver's conflict metric, which quantifies how difficult it is for a solver to find a valid solution. Now, let's talk about the findings. The researchers observed a significant decline in the performance of various large language models as the complexity of the puzzles increased. This decline was so pronounced that they termed it the curse of complexity. For instance, models that performed adequately on simpler puzzles struggled considerably when faced with puzzles of medium complexity, and their accuracy dropped to nearly zero on the most complex puzzles. Interestingly, increasing the size of the models didn't substantially improve their performance on these difficult puzzles. Even when they used larger models or provided more computational resources at inference time, a concept they refer to as scaling test time compute, the models still couldn't overcome the curse of complexity. The team explored several strategies to enhance the logical reasoning abilities of these models. One such strategy was best of n sampling, where multiple solutions are generated and the best one is selected. While this approach showed some promise, it wasn't enough to break the curse. They also experimented with backtracking mechanisms, which involve the model reconsidering previous decisions when a contradiction is found, and self-verification prompts, where the model is encouraged to check its own work. These methods provided marginal improvements, but didn't fully address the core limitations. So, what does all this mean for the future of AI and logical reasoning? The study suggests that simply making models bigger or giving them more computational power isn't sufficient. Instead, there may be a need to train models to reason step by step explicitly, much like how we teach students to show their work in math class. This process, often referred to as chain of thought reasoning, could help models navigate complex logical problems more effectively. In conclusion, ZebraLogic offers valuable insights into the limitations of current large language models when it comes to logical reasoning. By providing a structured and quantifiable way to assess reasoning abilities, this framework highlights the areas where these models excel and where they fall short. It also underscores the importance of developing new strategies to enhance reasoning capabilities, moving beyond scale alone. Thank you for joining me in this exploration of ZebraLogic and the fascinating challenges of logical reasoning in AI. Until next time, this has been New Paradigm AI Research Summaries.